Good morning all. This is Ambika, Assistant Professor, Department of ISE, and today we will be discussing authentication, which will comprise of one-way authentication, mutual authentication and dictionary attacks. So what is authentication? Authentication is nothing but proving the genuinity of an identity. So authentication can be defined as determining an identity to the required level of assurance. That is, you are guaranteeing a certain identity. Then authentication is basically the first step for any cryptographic solution. Why? Because unless we know who is actually communicating, there is no point in encrypting any message. And authentication is basically any process by which a system verifies the identity of who a user is and who is the person who is wishing to access any system. So authentication may be implemented using various credentials. Mostly and usually most commonly used credentials is basically your user ID and your password. And alternatively, authentication may also be implemented by using smart cards, an authentication server, or even a public key infrastructure. Public key infrastructure we have studied in the previous unit, which comprises of your certifying authority, your tokens, registration authority, and your certificate management system, all of which is used to provide authentication for a particular user or an entity. Now we move on to one-way authentication. Now what is one-way authentication? So here it states that we know that a distributed system is susceptible to a variety of security threats. What is a distributed system? Distributed systems are nothing but systems wherein the components are located on different networked computers. So when you have components that are located on different network computers, the likelihood of security threats is much greater. And anybody can impersonate another, and hence authentication becomes an important requirement. So authentication is basically nothing but a process wherein one principal verifies the identity of another principal. So in one-way authentication, what happens? There is only one principal that is verifying the identity of the other principal. Now, what are the different ways of one-way authentication or proving who we are? So first is what you know. Now, when it comes to what you know, we are basically talking about passwords and secret keys, etc., which is known what to that person or the individual. And next, coming to where you are. So where you are is your IP addresses. So typically within an organization or within a college, etc., you have a particular IP address, and it is only through that IP address that you are communicating, and so it becomes easier for the verifier to identify where certain traffic or internet traffic is coming from. Then thirdly, coming to what you are. So recently we have all seen that biometrics is a big way of identifying a person. So your biometrics can be anything depending on your physicality or an individual person's physical appearances, be it your fingerprints or your iris scan or voice modulation, etc. Then last is what you have. So what you have, you can again prove your identity with your smart cards, your ATM cards, like maybe sometimes an example could be of your Aadhaar card also, wherein you are proving the identity. So next, under authentication, we have two kinds of authentication. One is the password-based authentication, and the next is message digest of a password authentication. So now what is a password? We all know that password is nothing but a string of alphabets or numbers and special characters, which is supposed to be known only to the entity or the person that is being authenticated. So all of you have your Gmail account or Yahoo account passwords, which all comprises of a string of alphabets, numbers and special characters, which technically is supposed to be known only to you. So as I already mentioned, the two methods of password based authentication are: first one being your clear text password authentication, and the next is your message digest of password authentication. Now if you just can look at the diagram here, we will know what you're talking about. So how does it work? The working of the clear text password authentication. So your first step in your clear text password authentication, what happens is you're prompted to provide your user ID and your password. So once you are prompted for your user ID and password, the user then enters the user ID and the password that is he has. So this user ID and password is then sent to the server. And please mind you, this is all done in clear text, and that is why it is called your clear text password authentication. So once the server receives the user ID and the password, the server will validate the user ID and the password. And then once it is validated, the user ID and password is validated, that is, it says yes, this user ID belongs to this certain person or entity, the server will then authenticate the result. Authenticate meaning it will either accept or it will send a rejection request back to the user, rejection result back to the user, and then this is informed to the user accordingly. So in this illustration we see that you have your user and you have your server. Your user is sending the login request to the server, that is, it is sending the user ID and the password to the server, and the server will do the necessary validation and send back the authentication results of either accepting or rejecting the user. Now again, like I said, please note here the user database stores the passwords in clear text format, and hence it is known as clear text password authentication. So what is the disadvantage of the clear text password? So main disadvantage, as we all know, database contains the password in clear text. Of course, it is advised that the password should not be stored in clear text, because it is very easy for the attacker to obtain these passwords. And so instead of storing it in clear text, the password should be stored in an encrypted form within the database. And next, when the password travels in clear text from the user's computer to the server, if an attacker breaks this communication link, it is very easy to obtain the clear text password, and hence this clear text password method is not very advantageous. Alright, so now we come to the working of the message digest of the password authentication. Now please recall that we have already done message digest in the previous modules while in class. So what is a message digest? Message digest is basically a cryptographic hash function which contains a string of digits created by a one-way hashing formula. So message digests are basically designed to protect the integrity of a piece of data, to detect any changes or alterations that may be done to any part of the message. Again, please recall the MD5 algorithm that we studied in class. So now coming back to this password based message digest based password authentication. So here what happens is, so when a user needs to be authenticated, he again enters the user ID and the password. So the user's computer will compute the message digest for that particular password. Then the user's computer will send the message digest of that particular password back to the server, and the server will then compute the message digest of the particular password that has come from the user, and if it is verified and validated, it will send back the accepted or the rejected result back to the user. So that is what is happening here. Again, if you see the diagram, you have your user and your server, and so what happens is the user is sending in the login request, that is the user ID, and the message digest of the password that the user has entered. It is sent to the server. The server will then verify from the user's database the user ID and the corresponding message digest, and this server will then, based on the verified message digest and user ID, it will send back the result, accepted or rejected result, back to the user. So again, message digests are basically designed to protect the integrity of a piece of data. The piece of data being here is your password. So this message digest can detect if there are any changes or alterations done to any part of the message. So now we come to the disadvantages of the message digest of passwords. So what are the main disadvantages? So first of all, an attacker might not be able to compute the original password back from the message digest of the password, but what he can do is he can simply copy the user ID and the corresponding message digest of the password, and then submit the same thing after some time to the same server as a part of the new login request. So when this happens, the server has absolutely no way of knowing that this login attempt is not from the actual valid user, but it is actually an attacker who is sending the message digest and the user ID. So this kind of an attack is known as a replay attack. Why is it a replay attack? Because what the attacker is doing is he simply replace the sequence of actions of a normal user. Now, to improve the security and to detect this so-called replay attack, what we have to do is add some kind of a randomness to the message digest to ensure that the replay attack is foiled and does not occur. So now coming to the steps for adding this randomness. So as always, what happens is you have your user and your server. So now initially in the first step, the user will only send the login request, which comprises of the user ID to the server. Now at the server end, within the user database of the server will have a copy of the user's ID and the message digest that is derived from the user's password, which is already stored within the server. Now once the server receives this user ID, what the server does is it first verifies that this user ID actually exists within the database of the server, within the user database of the server. And once that verification is done, the server will send a random challenge back to the user. This random challenge is sent in the form of a plain text back to the user. And now what is a random challenge? It is nothing but a random number that is sent back from the server to the user. Now this server, once it receives the random challenge, what it does is the user's computer will encrypt this random challenge or the random number that is received from the server, and using the user's message digest and which is derived from the user's password. Then once this random challenge is encrypted using the user's message digest that is derived from the user's password, this encrypted random challenge is sent back to the server. This encrypted random challenge is then verified by the server, and then if it is authentic, the authentication result is sent back as either accepted or rejected back from the server to the user. So this is how adding randomness works. So when the user sends the login request to the server, first step is that the server will verify that this user ID actually exists in the database. If it is guaranteed that this ID exists in the database, it sends a random number back to the user. This random number sent back to the user is in the form of a plain text. The user will receive this random number or random challenge, and it will encrypt this random number using the message digest that is derived from the user's password, and this encrypted random challenge is sent back to the server. Finally, the server will verify this encrypted random challenge, and it returns the appropriate message or rather authentication result as accepted or rejected back to the user. And that is how the message digest authentication works. So this is what is mentioned in these steps 4 and 5 as well. Now here, please note that the random challenge value is different every time. So here it is mentioned the random challenge value is different every time. Therefore, the random challenge encrypted with the message digest of the password would also be different every time, because when the random number keeps changing, obviously when you encrypt it with the message digest of the particular user password, that should also be different, and hence this replay attacks can be easily detected and stopped. Now, what is the disadvantage of password-based authentication? Now, there are a number of disadvantages of this password-based authentication. So, first one, typically within an organization, there are a huge number of applications, networks, shared resources across the internet. Now, these applications, since they are different, may have varying or different needs of security measures, and each resource may demand its own username and password. So when you have different n number of applications, networks and shared resources over one particular LAN or internet, these applications will also have different varying needs of security measures and different usernames and passwords, which becomes very difficult to keep track of. So in that case, end users and network administrators will also have to keep a large number of user IDs and passwords that is to be used with different various applications, which is a very difficult task. And password maintenance, as we all know, is a very big concern for security system administrators. So I'm sure you yourself, if you have different number of login accounts, and if you keep having different passwords, maybe say you have 5 different accounts and you have 5 different passwords, it is very difficult. So you can imagine in huge organizations wherein password maintenance for a huge number of applications would be a huge task. So many organizations also specify password policies, which again is not very easy to follow. So these are the many disadvantages of this password-based authentication. So now after the password-based authentication, we come to certificate-based authentication. So as we previously saw, digital certificates are also used for authenticating a particular person or identity. So authentication is based on the digital certificates of the user. So in the public key infrastructure, digital certificates are used for secure digital transaction, and because of this secure digital transaction, it can also be reused for authentication. But what are the issues of this certificate-based authentication? So first issue may be the misuse of someone else's, or rather the main issue may be the misuse of someone else's certificate. And in order to tackle this issue, certificate-based authentication is a two-factor process, as in there are 2 types of authentication. So first factor would be to have something. When you say have something, it basically refers to an authentication token which can be used to authenticate. And next is to know something. Now know something is something that the person will have for himself. It is similar to a password. So here in this case it is a PIN also known as your personal identification number, and this should be protected by the user or the identity that has this PIN. So now how does your certificate-based authentication work? So firstly, you create, store and distribute the digital certificate. So as we previously studied in PKI, you have your certifying authority which will create, store and distribute the digital certificate. So as mentioned here, certificates are created by the CA and sent to the user, while a copy is sent to the server also. Now, since implementation of the certificate-based authentication occurs at the server, so why does the server require a copy as well, apart from the user, is because server is the one who will do the authentication. Now, next coming to the login request. So obviously, like in the password-based authentication, the user sends his ID only. Now, the server creates a random challenge. What is this random challenge? Again, it's a random number to add randomness in order to confuse the attackers. So the user ID, when the server creates a random challenge, the user ID's validity is checked, and then it sends a random challenge as a plain text back to the user. So this is similar to the message digest method where we added a random challenge. So then what happens? The user signs this random challenge. When the user signs the random number that is received from the server by using its private key, the user's private key is stored in the file in the user's computer. So to access this private key file, user has to give a correct password. Then the user sends the signed random challenge or the signed number back to the server. So server returns an appropriate message back to the user. This appropriate message could be your accepting or your rejection result. So if you see the diagram here, you again have your user and you have your server, and the server first sends the user ID or the login request, using only the user ID to the server. Then in the server end, what happens? The user database, in the user database, the digital certificate of the user is stored, and it contains the user ID and the public key of the user. So server, what it does is, he will verify the existence of this user's login ID, and once that is verified, the server again creates your random challenge or the random number, and this is sent back to the server in the form of a plain text. The user receives this random challenge and he will encrypt this random number that is received using the user's private key here. Please note that here the user is using the private key to encrypt the message and not the message digest of the user's password as done previously. Okay, so once this encryption is done, this encrypted random challenge is sent back to the server. Server again will verify this encrypted message or encrypted random challenge that is received and returns the authentication result back to the user. So in certificate-based authentication, encryption is done using the private key of the user, whereas in password-based or rather message digest based password authentication, the message digest of the user's password is used to encrypt the random challenge. So now we come to mutual authentication. Mutual authentication is a two-way authentication. So please remember, previously we studied one-way authentication, wherein only the client used to send or the user used to send a login request to the server, irrespective of whether it trusted the server or not. But in mutual authentication, which is a two-way authentication, here it is a process or a technology in which both entities, that is the user or the client as well as the server, within a communication link has to authenticate each other. Otherwise, the communication will not be established. So here the client will send a communication or a request to the server only if it trusts the server, and vice versa. The server also has to trust the client's certificate. So this process will reduce the risk that an unsuspecting network user will by mistake reveal any security information. This kind of mutual or two-way authentication will also reduce the risk of replay attacks, because the client will have only one or rather will only send one certificate to the server for authentication, and then even if there is a repeatedly sending of different certificates, then only the certificate with the latest timestamp is used for the authentication. Now please note that mutual authentication is not two-factor authentication. In two-factor authentication, what happens is the authentication occurs by two means of identification that is done by using a physical token or a password. But mutual authentication is wherein the client and the server within a communication link has to authenticate each other. Now mutual authentication has three mechanisms. So first one is your shared secret key based authentication. So in your shared secret key based authentication, what happens is you have one secret key for the user as well as for the sender as well as the receiver. So shared secret key based authentication is done using the traditional symmetric key cryptography. So here there is a problem of assuming that there is no man in the middle attacker who is trying to read your or spoof your communication. Okay, so that is one of the disadvantages of the shared secret key, in fact. But here we assume that there is no man in the middle, and there are various algorithms used to prevent such attacks. Most commonly used algorithms are your Diffie-Hellman and Authentication Key Distribution Center, Kerberos, Needham-Schroeder, etc. Diffie-Hellman we have already studied in class. Kerberos and Needham-Schroeder we will be studying next. Okay, so this is one mechanism of your mutual authentication. The first one being your shared secret key based authentication, also known as your symmetric key cryptography, already studied in class. We now come to the next mechanism, which is your asymmetric key based authentication, also known as your public key encryption method. So in asymmetric encryption scheme, anyone can encrypt your message using your public key, but only the person who holds the paired private key can decrypt it. So when we say paired, it has to be paired to the public key in order to decrypt the message. Now this system is also susceptible to attacks. So here in asymmetric key based authentication, most common attack is your spoofing attack or your man in the middle attack. So for example, in spoofing attack, your public key A, which is claimed to be publicly of a particular user Alice, but it might in fact be belonging to the man in the middle attacker here named as Mallet. So this problem also may occur in your asymmetric key authentication. But the most common solution to this problem is the use of public key certificates and certificate authorities for them in a public key infrastructure. So we already saw in the public key infrastructure system, you have your certificate authority that will provide a proper digital signature on the certificates that is sent from your public key, and this is done in order to authenticate both the parties, the sender as well as the receiver, that the message that is coming from either of them actually belongs to the user and the sender. Now last mechanism is your timestamp. What is your timestamp? So basically your trusted timestamp is the process of securely keeping track of the creation and modification time of a document. So here you are timestamping a particular document with the time that it has been created or modified. So security here means that no one, not even the owner of the document, should be able to change the time of the document once it has been recorded. And this proves that the timestamper's integrity is never compromised. So the administrative aspects involves setting up a publicly available trusted timestamp management infrastructure to collect, process and renew the timestamps. So this is done so that there is no tampering of the timestamps that has been put on the, or rather set on the message that is being sent. So there is a very good video that you can visit on YouTube in order to understand mutual authentication better. Now coming to your dictionary attacks. So what are your dictionary attacks? So this dictionary attack is a method of breaking into a password protected computer or a server by systematically entering every word in a dictionary as a password. The dictionary attack can also be used in an attempt to find the key necessary to decrypt an encrypted message or a document. So basically it is a form of a brute force attack technique for defeating a cipher or authentication mechanism by trying to determine its decryption key or paraphrase by trying out hundreds or millions of likely possibilities. So dictionary attack usually tries only those possibilities which are most likely to succeed, because many users and businesses use very ordinary words as their passwords. However, a dictionary attack is rarely successful against systems that employs multiple word phrases. So that is why in order to keep your passwords safe, many organizations tell you to use passwords which have a lot of strings, characters, numbers, alphabets, etc. and it has multiple word phrases. It is also unsuccessful against systems that employ random combinations of uppercase and lowercase mixed with numerals. So if you go to your banking passwords, etc., they ask you to use one uppercase, one lowercase, a few special characters and numbers all in your particular password. So in those systems, the brute force method of attack can sometimes be effective, although this approach can take a long time to produce results. Why? Because you have to try every number combination, every alphabet combination, either uppercase, lowercase, etc. So now what type of password can be easily hacked by a dictionary attack? Now we know that most passwords are chosen by users, and it can be reasoned that most passwords are or usually are or contain most common words. So most attackers, what they do, they are smart, so they take this into account and make use of word lists in combination with common passwords, such as firstly variations of a user's first or a last name, your initials, your account name and other relevant personal information such as your address, telephone numbers, pet's name, etc. Next, most commonly used words from various databases such as male and female names, places, cartoon characters, films, myths and books. Then spelling variations and permutations such as replacing the letter O with the number 0 using random capitalization and common word pairs. So this is how these dictionary attacks, or rather the attackers, will try to figure out the password that an individual is trying to use. How to prevent these dictionary attacks? So first one is your delayed response. So a slightly delayed response from the server will prevent the hacker or spammer from checking multiple passwords within a short span of time. Next, of course, is to strengthen the password requirements. How do you strengthen it? You increase the password complexity by using specific symbols, special characters, numbers, uppercase letters, lowercase letters, etc. Then refreshing of your passwords. So again, most of your banking applications will ask you to recycle or change your passwords every 30 days or 90 days to protect against your dictionary attacks. Lastly, of course, to lock your accounts, systems are configured to lock an account after a specified number of attempted logins. So just something as simple as your phone. So I think a few phones have the capacity of entering only passwords of being entered 3 times. So after the 3rd time it is entered wrong, your account is locked for maybe a few hours or a few minutes. So similarly, like in other applications also, if you enter wrong or different passwords, it is locked. The account is locked for a specified number of hours or minutes. So that completes your dictionary attack. Thank you for your time.